As a part of the New Frontiers NASA program, New Horizons is an unmanned space mission with the main objective of exploring and collecting data from the Kuiper Belt, Pluto, and Charon, its largest moon. The Kuiper Belt, studied for more than 90 years, is the largest structure of the solar system, which contains more than 100,000 objects with their diameter bigger than 100 kilometers, and these could be formed by frozen organic elements from the solar system formation. Pluto and Charon constitute a binary orbital system, the first one found in our system. The atmosphere, formation, and relation with the Kuiper Belt are being investigated of both celestial bodies. Because of the fact that the system was in its nearest position from the Sun, the US National Academy of Science established a priority in this study, and after dismissing some projects, NASA finally authorized the New Horizons mission on November 2001. The mission required the gravitational assistance of Jupiter, plus some information about this planet could be gathered. The launch date was compulsory set for January 2006. A race against the clock had started. New Horizons team had only 4 years to build the spacecraft. New Horizons is a high-tech, robust, lightweight spacecraft designed to withstand a long and difficult journey. The spacecraft's high-gain antenna dish is shaped to receive even the faintest radio signals from home, a necessity when the mission's main target is 3 billion miles from Earth and round-trip transmission time is 9 hours. The New Horizons primary structure includes an aluminum central cylinder that supports honeycomb panels. The interface between the spacecraft and its power source houses the propellant tank and serves as the payload adapter fitting that connects the spacecraft to the launch vehicle. The spacecraft is designed to retain heat like a thermos bottle. It is covered in lightweight gold-colored multi-layered thermal insulation blankets, which keep the spacecraft operating at between 10 to 30 degrees Celsius. The propulsion system on the New Horizons is used for course corrections and for pointing the spacecraft. It is not needed to speed the spacecraft to Pluto. That was done entirely by the launch vehicle with the boost from Jupiter's gravity. New Horizons' electrical power comes from a single radioisotope thermoelectric generator, which provides power through the natural radioactive decay of plutonium dioxide fuel. Horizons does not have a battery for storing power. New Horizons packs the most advanced suite of cameras and spectrometers ever sent on a first reconnaissance mission. The New Horizons science payload consists of 7 instruments. ALICE is a sensitive ultraviolet imaging spectrometer designed to prove the composition and structure of Pluto's dynamic atmosphere, giving scientists the first complete picture of Pluto's atmospheric composition. Ralph is the main eyes of New Horizons and is charged with making the maps that show what Pluto, its moons, and other Kuiper Belt objects look like. Ralph will take images as New Horizons approaches, flies past, and then looks back at the Pluto system. It also takes stereo images to determine surface topography and helps scientists refine the radio and orbits of Pluto and its moons. It will aid the search for rings and additional satellites around Pluto. REX is a radio signal processor that will prove Pluto's atmosphere and search for one around Charon. Radio signals are beamed from the Earth to the spacecraft as it passes behind Pluto. REX will also measure the weak radio emissions from Pluto and Charon. Scientists will use that data to derive accurate temperature measurements. Scientists will also measure the masses and densities of Pluto and Charon and the masses of additional KVOs. LORRI, the eagle eyes of New Horizons, is a panchromatic high-magnification imager. It's essentially a digital camera with a large telephoto telescope. LORRI will select sections of Pluto's sunlit surface that will give scientists an unprecedented look at the geology of Pluto, Charon, and additional KVOs, including the number and size of craters on each surface. The SWAP instrument will measure interactions of Pluto with the solar wind by measuring how and where the solar wind is blocked by Pluto's escaping atmosphere. SWAP will determine the escape rate of atmospheric material from Pluto. Finally, the Student Dust Counter detects microscopic dust grains produced by the collisions among asteroids, comets, and other objects during New Horizons' long journey. The SDC counts and measures the size of dust particles, producing information on the collision rates of such bodies in the outer solar system. SDC will also be used to search for dust in the Pluto system. PEPSI is the most compact, lowest power directional energetic particle spectrometer flown on a space mission, and it will likely get its first taste of Pluto's atmosphere when the planet is still millions of miles away. By using PEPSI, scientists will be able to tell how quickly the planet's atmosphere is escaping and gain new information about the composition of the atmosphere. The launch rocket used for New Horizons was an Atlas V, operated by the Lockheed Martin Boeing joint venture. With its first launch in 2002, Atlas V has had an almost perfect success rate in more than 50 launches. The Atlas V launcher uses a Russian-built RT-180 engine burning kerosene and liquid oxygen to power its first stage, and an RL-10 engine burning liquid hydrogen and oxygen to power its Centaur upper stage. In particular, the configuration used was a 551, which was the first one using 5 solid rocket boosters. Previous Atlas V launchers had used 0, 2 or 3 solid boosters. New Horizons started its journey on January 19, 2006, and it was traveling through the Earth's atmosphere as it started to burn its second and third stages. When the third stage came apart, it was traveling at around 16 km per second. After the gravitational shift from Jupiter, which made the mission 3 years faster, New Horizons started the hibernation process, which lasted for nearly 2,000 days, and it finally woke up in December 6, 2014. Then it started the Pluto approach, and scientists needed to test the steps that the spacecraft had to do for the best results. So they took photos of Pluto and they adjusted New Horizons' trajectory using its propulsion. The approach was dangerous due to the small particles that orbit around Pluto, but the scientists in charge of safety decided to point the giant antenna of the spaceship forward, because it can absorb all kinds of collisions. The approach to Pluto on July 14, 2015 went down perfectly, and a lot of data was stored in the New Horizons, which started to send it to the Earth. Then the New Horizons started its journey to the Kuiper Belt. The mission results were magnificent, and nearly 100 studies came down from all the mission. Humanity finally explored the coldest, darkest frontiers of the solar system. This has been the first mission to the Pluto and Kuiper Belt, the fastest spacecraft ever launched from Earth, and the farthest distance the spacecraft has traveled to begin its primary science mission.